Greetings from Sri Krishna Science Center, Patna. Today we are going to demonstrate some experiments on resistances which are connected in series and parallel. First of all, when we hear about resistance, one may wonder what is resistance. And to talk about resistance, we'll first talk about currents. When we say electric current, we mean the flow of charge. And in our context, these charges are nothing but electrons. And as we know that all materials are made up of atoms that consist of electrons, and in particular, conductors have free electrons which are responsible for these electric currents. But on the other hand, the flow of these electrons are obstructed by other ions and the arrangement of atoms as a whole. So, the obstruction to the flow of currents, either by the ions or the arrangement of atoms, is called resistance. It is measured in units of ohm in the SI unit and denoted by the Greek letter omega. So today we will demonstrate the different style of connections of resistors on a breadboard, measuring with multimeter, and we will also talk about some applications of these connections. So for our demonstration, resistors connected in series and parallel, we choose three resistors, and we'll measure with using a multimeter. So one is measuring approximately 2.2 kilo ohm. Approximately 2.2 kilo ohm. And this also approximately 2.2 kilo ohm. So these differences can arise due to some impurities, imperfection of the real resistance. So now, series resistance means these resistors will be connected from end to end in a serial fashion. For example, we have the first resistor here. At the end of this resistor, we'll add another one, and again at the end of this one, we'll be adding another one in a serial fashion. It originated from here, ended here, and at the same point it started from here and ended here, and from there, here and here. So in a breadboard, these lines are considered to be the same point, as we can see from here. So now 2.1, 2.1 and 2.1, when added serially, we will get approximately 2.2, 2.2, 2.2, approximately we will be getting 6.6. So approximately we are getting the exact value, approximately 6.6. Now however, in a parallel combination, so at a single point, all the resistors will be connected at a single point. One end of each of the resistors are connected, and at the same time the other end will be connected all together at a different single point. So here we are getting around 0.72 kilo ohm. So in parallel combination, it is seen that given the same amount of resistances, we get a lesser or reduced equivalent resistance across the terminals. Likewise, when we supply some voltage, let's say let's say we are providing 5 volts, and on the multimeter we will be reading in the voltmeter. So we are supplying a 5 volt coming from one resistor at the point where we are connecting the resistors parallelly, and the other end of the terminal here. So we are supposed to get approximately 5 volts. Whatever is coming from the source, we are getting the same voltage across one resistance around 5 volts, the voltage drop across another resistance, another 5 volts, voltage drop across the third resistor, again it is approximately 5 volts. So these parallel combinations are used for our domestic appliances because all the plug points, if they are not connected parallelly, there will be a problem, because most of our domestic appliances are rated at 220 volt AC. So if they are not by connecting the parallelly, they all are getting the 220 volts AC. Now moreover, even if I pull out one of them, still the voltage drop across the whole circuit will be 5 volts. So these, for example, these resistors can be in real life. One can be a washing machine, one can be a refrigerator, and one can be a television. Now even if I turn off the refrigerator, we still have the voltage drop across them. Now on the other hand, if I connect the resistors in a serial fashion, serially, the total voltage across the whole circuit has to be 5 volts, at least approximately. So we are getting it right, exact 5 volts. However, this is a refrigerator, this is a television, and this is a washing machine. Now, across each component, here we are getting only 1.6 something, 1.64. Again, 1.6, yeah, approximately 1.66, 1.66, and 1.66. So since all of the resistors have the same resistance, the voltage drop across each of them becomes different, and they serially add up to around 5 volts, 1.6 times 1.6 and 1.6. So when one of the components is pulled out, let's say in domestic appliances, the supply comes from, the source comes here, and our domestic connection, if it has been connected in series, we shut down one of them, then there will be no current flow. So these are the basis of connections of resistance in series and in parallel. Thank you.